Hi everyone, my name is Jayantach. I'm studying in Sri Venkateshwara College of Engineering in third semester, USN 1VE 23CD020. Subject Mathematics. Subject code BCS 301. Today I'm going to explain about chi-square distribution, a test of goodness fit. Chi-square distribution, a test of goodness of fit. The chi-square distribution is a statistical distribution that is commonly used in hypothesis testing, specifically to assess the goodness of fit of observed data to expected frequencies. This presentation will explore the concepts and application of the chi-square distribution. Let's move on. Introduction. There are three types: understanding the data, second chi-square test, third real world application. First, understanding data. In many fields, we aim to understand the relationship between variables and how data fits our expectation. Second, chi-square test. The chi-square test of goodness of fit helps us determine if the observed data matches the expected frequency from a theoretical distribution. Third, real world applications. Applications spans diverse areas including market, research, science, etc. What is chi-square distribution? First, definition. The chi-square distribution is a continuous probability distribution that describes the sum of squared deviation from the expected values of independent, standard, normal random variables. Degrees of freedom. The shape of the distribution is influenced by the degrees of freedom, which is number category minus 1. Right skewed. The chi-square distribution is always right skewed with a longer tail towards the right side of the graph. Chi-square test of goodness of fit. First, hypothetical distribution. We start with a theoretical distribution or model that we believe represents the population. Observed data. We collect data from a sample and record the observed frequency in each category. Comparison. We compare the observed frequency to the expected frequency based on the distribution. Assumption and requirements. Independent observation. The data points should be independent of each other, meaning one observation doesn't influence another. Expected frequency. All expected frequency should be at least 5 or some adjustments to the test may be needed. Categorical data. The data should be categorical, mean it can be into distinct groups or categories. Null hypothesis. Null and alternative hypothesis. Null hypothesis is also represented as H naught. There is no significant difference between the observed and expected frequency. The data fits the theoretical distribution. Alternative hypothesis is mentioned as H1. There is a significant difference between the expected frequency. The data doesn't mean theoretical distribution. Test static calculation. The chi-square test statics is calculated as the sum of squared differences between the observed and expected frequency divided by the expected frequencies. Interrupting the p-value. There are two types: low p-value, high p-value. First, I am going to discuss about low p-value. If the p-value is below the significance level, usually 0.05, we reject the null hypothesis. This suggests that there is a statistical significant difference between the observed and expected frequencies. High p-value. If the p-value is above the significance level, we fail to reject the null hypothesis. This suggests there is not enough evidence to conclude that the observed data significantly differs from the expected frequencies. Applications and examples. Genetics. Testing the Mendelian inheritance patterns for traits. Market research. Comparing the observed preferences of consumers to expected proportions. Social science. Analyzing survey data to see if opinions align with a theoretical model. Limitation and consideration. There are three types: sample size, second expected frequency, third assumption. Chi-square test is sensitive to small sample size. Larger samples are generally preferred for more reliable results. Expected frequencies. If expected frequencies are too low, the chi-square test may not be accurate. Adjustments or alternative test may be needed. Assumptions. Violating the assumptions independence and frequency can be validated for the test. Conclusion. In conclusion, chi-square test is a powerful tool for accessing the goodness of T in categorical data. By understanding its principles and applications, we can harness its potential to draw meaningful conclusions from our data. Thank you. Have a nice day. Please like and subscribe to my channel.